So this will be our class 5 on our hands-on practical class on data science, and we are going to be talking about feature selection. The last class we discussed pre-processing, and prior to that time we discussed basic visualization, and in the first class we discussed obtaining your data and performing basic data analysis. And the next class, which is today, we are going to be talking about practical feature selection with Python. We also have the steps we are going to follow and the code snippets you need. Everything is also laid out. So I'm actually just following procedures I've actually laid out for you right here so that it can be easy for you, for everyone to follow. So there are 5 types of aspect of feature selection. But first, what is feature selection? Now, if you are trying to visualize your data, you can plot it in 2D axes or in 2-dimensional axes, that is X, Y, and you can see the trend in this data. For instance, if I open the visualization class, and you can see that we have our data plotted in 2D, and in that way you can see how the variables interact. In this case, for instance, you can see this particular variable here, value here is higher than other ones. You cannot actually understand it easily. Again, you can also see what is happening here and so on. This is 2D. Now I can also plot in 3D, and this is a different class. You can also see your data in 3D, maybe like a box. You can actually pan the box around to see how the data interact. But when you have data that has 4 features, that becomes a problem. You can't actually plot easily in 4 dimensions. What about 5 dimensions? What about 6, 7, 8, 50 or 100? Once the dimension of the data is becoming very high, it becomes difficult to understand your data set. And that is why we need a way to select the features that are more important than others, and that is the concept of feature selection. So you can't just select any feature you like. You need to use machine learning approach or data science approach or analytics approach to select features that actually are more useful to analytics, because some features, as I told you in the Titanic data set, some features might not actually be very useful. I think we talked about that in pre-processing, where we actually have to eliminate some features or even drop them completely because they are not very useful in the final result of your data and of your analytics. So today, let's now talk about feature selection. And this is a very important topic, because if you perform feature selection effectively, then your results will be the final result will be robust, and you have very good result at the end of the day. Now again, as I mentioned, this is a practical class, so I'm not going to be talking about so much theories. Take some time to read it in my website here. So let's go immediately to the first aspect of feature selection, or to the first method of feature selection, and that is univariate feature selection. Univariate simply means one single feature. And when we talk about feature, we are talking about variables. So let's go ahead to get started right now. I'm going to just click on new and open a new Python 3 notebook. And I'm going to call this notebook class 5 feature selection, class 5 feature selection. All right. So we want to now perform feature selection on our data set, and it's going to be univariate feature selection. I'm going to import a data set I have on my system. So let me first import pandas. Import. Okay, I think I have the code here in my website, but I'm actually going to be typing them out. And also, that is what I tell you to do. Type the codes out. The more you type it, the more you get used to it. So don't do copy and paste. So simply start typing it out. This is a practical class. So don't keep watching. Just go and start doing it. Be looking at how I do it and be doing it at the same time. So this is how we are going to improve in data science. So let's now import our data set and take a look at all these features, about 13 features, and see how we can perform feature selection to select important features. So I'm going to say import pandas as PD, and we're also going to import numpy as np, and we're also going to import the feature selection module library from sklearn. So I'm going to import sklearn.feature underscore selection as fs, giving an alias fs, and also we are going to import chi-square from sklearn.feature feature selection import from sklearn feature selection, import chi-square. Now we want to perform univariate feature selection. Univariate feature selection simply means look at these features individually and select which ones are more useful or seem to be more important in explaining the target variable. The target variable is the same as a dependent variable. The features are the independent variables. We also call them the features or the attributes, right? And then the other variable, we call it the target variable, the class. All right, so now I'm going to import the wine data set. I'm going to call it wine df, and I'm going to specify the path I'm going to execute. I'm going to just take a look at our wine data frame, and you can see that we have the wine data frame imported, and you can see that it has 14 columns. Now the target column is the wine, which is this one here, which is wine, which is made up of 3 different classes of wine. The other columns, which are 13 of them, they are the attributes that actually will determine what kind of wine the record or this observation is. So all these attributes, we have alcohol, we have malic acid, ash, magnesium, phenol, flavonoid, non-flavonoid, phenols, prurans, and so on. Not all of them are equally useful, right? So this is a small data set, but the same principle applies. Not all these attributes we suspect are very useful in predicting the kind of wine that's going to be produced. So let's extract the features that we think, or the system is going to perform univariate feature selection to select which features are more important than others. So the first thing we want to do is to separate this data set into the X and Y, into the dependent and independent, and the X is the attributes, which is alcohol, malic acid, and so on. But the target, the Y, is wine. So I'm going to say wine X, and now if we look at the wine X, we are going to see that we have this very column here. So this is our Y, right? The variable we want to predict. And now we're going to do the same thing for X. We're going to this should be Y. This should be Y. X will be all the attributes, and we are going to now say wine X is equal to wine underscore df with iloc, and now we are selecting all the rows as well, and the column will be from column 1 this time to the end. So we specify column, we don't specify nothing. It's going to take all the way to the end. So this is our X. Now you can see that the X values or attribute does not have the Y, right? Does not have the wine column. And if I look at the Y this time, you can also see that it doesn't have the X. So we split our data into 2 parts, but we also have to convert these values to arrays, because what we have now, they are still data frames. So I'm going to say the values. So it's going to convert them to arrays. So I'm going to run. So we have them as arrays. The reason is because we need to use them as arrays if we want to perform univariate feature selection. All right, so we now want to perform feature selection to select the best 5 attributes or the best 5 features from the data set. I'm going to create a selector variable. Selector is equal to fs.select. So select k best means select the k best features. That's the name of the module that we're going to be used, which is available in feature selection in sklearn. So I'm going to select k best and specify the score function. So you don't have to worry about this, but this is actually the algorithm that actually does the actual selection internally. So it's going to be chi-squared, and k is equal to 5. Now you can change k to something else if you want. And I'm going to say results of this analysis of this selection is going to be selector dot fit and specify the data we want to use. So you can wine x and wine y. And finally, we want now, of course, I'm going to kind of run. Okay, perfect. Okay. So what is in the result? We now want to view the result, but before then, there is one more thing we need to do. We need to transform. So I'm going to say the best features. I'm going to place the best features, the results, the transform, the best features. I'm going to place the output in best features variable. So I'm going to say results dot transform and specify the features, which is wine x. This is the features. So it's going to be transform. There's a typo here. Transform is fine. All right. So what we now want to view these features. How do we know which features we've selected? So I'm going to just view them by saying our results dot scores. All right. All right. So what does this mean? So it now tells us that now these are the scores for each of these features, right? So there are 13 features. Remember, we have one alcohol, malic acid. So it assigns scores to these features, and you have for each of them you can now see what score is assigned to them. And I'm going to say the features. Let's look at the features now. It's going to be wine df. It's going to be wine x dot columns. A second, I think. Okay, these array does not have columns. So permit me to just create this one more time. So let me just take out this and use it here. Wine x. Is going to be the data frame this time. That's because I like to extract the columns from there. So I'm going to remove the values and I'm going to just check wine x, the data frame df, the columns. Okay. So now you have the columns here, and now for each of the column we have a score, right? Okay, so at this point you can see the scores for each feature. For alcohol, you have a score. For malic acid, there is a score. And so at this point, you can just select the best of the features you want. So in this case, you have the features arranged in order. So it's going to be, this is the smallest one and goes all the way to, actually I can just sort it. So let me sort it by using sorted and specify the array. So that's, okay, so now it's sorted, as you can see. So it has 0.74 for alcohol and 1,600 for the other, for the last one, which is proline, as you can see right here. So this is how to perform feature selection. Each feature is now assigned a score, as you can see. Let's now move to the next one. It's called recursive feature elimination. This is a feature selection technique that works by removing features recursively. So it's going to be removing a feature and check how the model performs. It's going to remove another feature. It's going to check how the model performs. It's going to remove another one. So as it removes, it's going to check which one affects the outputs recursively until it determines which are the best features. And that is why it is called recursive feature selection. There's an RFE library available in the RFE. There's an RFE module available in the sklearn library. So let's perform recursive feature selection. So I'm going to actually put a comment here: recursive feature selection. I'm going to mark down this cell by going to here and say mark down. Come here and say heading 1. Okay, so I'm going to just mark it down. Mark down. All right. So I'm going to so let's see. So have our data set. Now we need to import the linear model from sklearn. So I'm going to say import sklearn dot linear underscore model. Again, the recursive feature selection works similar to univariate feature selection. However, recursive feature selection is going to assign rank 1 to all the features that it thinks that is more important. So if we choose 5 features, we want to select 5 features, then it's going to assign these 5 best features rank 1. It's different from Univariate, which assigns scores to all the features, but Recursive is going to assign rank 1 to the best of the features. So I'm going to import linear model as LM. I'm going to execute this, and now we are going to create a linear model. So I'm going to rec model. That's the name I want to call the linear model. Linear model is simply an object or a variable that we can use to perform an analysis, in this case recursive feature selection. So lm the logistic regression max iteration is equal to 10,000. Okay, and we are going to also create an RFE object. It's going to be RFE and specify the model, which is the linear model we created, and specify the number of features we want to use. Again, I would like to, it's called n features to select. It's going to be three features. We want to select the 3 best features from the feature set or from the features. I'm going to say fit is equal to RFE dot fit, and want to specify the wine x, which we already have, and wine y. I'm going to use a variable because I already explained it. The variable is going to change the column vector onto an array. So dot variable. I actually could also not use it, but I think it's better I use it so that it doesn't give me any warning. So it gives me an error. RFE is not defined, so let me see. So we actually need to explicitly import RFE from sklearn as feature selection. So I'm going to say from sklearn feature selection import RFE. So I'm going to run this, and now this is going to work. Got an unexpected n features to select. So it's going to be n features to select. So I'm going to just shift this guy upwards, and let's run it one more time. Okay, perfect. So the next thing we are going to do now is to display the result. Let's now see how the result looks like. Now I'm going to use a function called zip, but before then, let's put the ranks in a variable called ranks. So I'm going to say ranks is equal to RFE, because now the ranks are available in the RFE object. So I'm going to say RFE.ranking, and the features is the wine df, the data frame dot iloc is from all the rows and column 1, all the rows, all the columns, all the rows, column 1 to the end. Okay, yeah, that is fine. So it's going to be dot columns. Yeah. So we have the ranks, so we have the features. So now for each of the features, we want to view the rank, and I'm going to now use a function called zip. Zip function is going to zip across, it's going to iterate these 2 lists at the same time. Meanwhile, if you want to look at the ranks, you can just look at the ranks like this, and you can see the ranks, but now we don't know which features correspond to these ranks. And also you can look at the features as well separately, and you can see, okay, I call this feature here, but it's actually features, so ranks, features. But we don't know which features correspond to which of the ranks, and we say that there are ranks that have rank 1. These are the features that are the important features or the selected features, and there are only 3 of them. You can see 1, 2, 3, and the next we have 2 which also have a good rank, but we actually wanted rank 1. So I'm going to use a zip function to actually display the features against the ranks. So I'm going to iterate these two lists at the same time. So I'm going to say for A and B, for A and B, actually I'm going to be A and B in Z. I'm going to now zip the two together. I'm going to say ranks, features and ranks. Yeah, so I'm going to print, I'm going to use a format, so I'm going to say F, I'm going to print A, so A is iterating the features, B is iterating the ranks, or maybe I can just call it F, F and R, okay, I think that would be more intuitive, right? So the features being iterated here, I'm going to put a semi and display the rank for that feature, maybe I can just say, so R, okay. Okay, so basically this is it. I'm going to close this quote here, and if I execute this, so it now displays all the features with the ranks. So you can actually just see for yourself that alcohol and flavonoids and OD have the best ranks, or they are the three features that actually they are selected, or they are the best features for this data set. You can actually change the number of features to select from here to 4 or 5 and see how it plays out. We are going to move on to the next one. Now we are talking about the next one is dimensionality reduction. Now, since this topic is a bit involving, I'm giving it a different class, which is immediately after this class. I'm going to now discuss dimensionality reduction. It also simply how to reduce the dimension of your data from very large data sets, number of features to a few number of features called principal component in case of principal component analysis. But there are different methods of dimensionality reduction. We have factor analysis, principal component analysis, we have singular value decomposition. But the key one, which is what we are interested in, is the principal component analysis, which we are going to discuss in the next class. We're also going to be touching on other ones, but just briefly. But if you want to learn a bit more, you can read ahead of me. I've also made some videos and classes on it. So these are materials you can use. I can read up about these things and maybe try a answer with them and see what you understand, so that the next class is going to become a bit a bit easier for you. Alright, so let's now go to the next aspect or the next method of feature selection, and that is called feature importance. Now see, all the names seems to be the same. You have feature selection, you have feature elimination, you have feature importance. We also just try to select key features or features that contribute mostly to the target output that we are trying to deduce. So in this case, we also assign scores to features based on how they are used for predicting the target variable. Simply put, sorry about this, it helps us to select the most important features, right? Some types of feature importance include calculated coefficients as part of linear model, correlation scores, permutation, importance scores, decision tree scores. Let's now use the extra classifier module, extra trees classifier module from skline to perform feature importance, and let's see how the outputs also is going to help us to see which features are selected. Alright, so I'm going to come here, I'm going to also create a markdown cell. I'm going to say let's perform feature importance. I'm going to mark down the cell by going to here and choosing head one and just mark it down. Okay, great. Alright, so we are going to be using the same data set, so we are not going to be importing any data set. So I'm going to simply import from skline the library or the module we are going to be using for feature importance. So it's going to be skline.ensemble. We're going to be talking about ensemble a little later as SE. So I'm giving it an alias SE. I'm going to create a model. I'm going to call it an extra trees classifier model. So I'm going to say SE.extra trees classifier. This is going to make more sense for you later on when we are going to be discussing classification. I'm going to be talking about decision trees and random forest. We are going to come back to meet these concepts one more time. So I'm going to fit the model with our data set. I'm going to say model.fit, specify the data set in the y(x), y variable. Now what's going to happen if I use y without using the variable function? It's going to give me a warning because it has a column vector or a column, one single column, but what we need is an array, right? So it's going to also use it, but it's going to complain. So let's just make it happy by using the rebel to convert this y(x) single column data frame to an array, a one-dimensional array. Okay, this is fine. So we have the importances, just like we have the scores or we have the ranking. This time we have the importance, right? So it's about the same, but so I'm going to call importances is equal to model dot feature underscore importances, and the features is the same. Features is equal to the y(df) or data frame dot iloc. Now this used to give me a problem, so in this case I'm going to select it's going to be from all the rows, 0 to the end. For the columns, you are selecting column 1, if I can remember, to the end like this, right? Yeah, I think I got it. Okay, maybe not. So columns row. Let me see. Features is equal to. Yeah, I think I got it. So I'm going to say that columns. Okay, so this is also correct. So if I look at the columns, let me just make sure I didn't mix up something. Yeah, sorry, I'm going to look at the features I selected. So all right, so this is correct. So I did it well, but it's all the rows. So, but we don't need the rows. We only need the columns. So let's also use the zip function to iterate through and print out the importance against the features. So and see what it's going to be. I'm going to say for feature and importance in zip, features and importances. Okay, I'm going to use a format f like this. I'm going to say f, the feature and column, and then the importance type I'm going to run at this point. Okay, we need to close the single quotes here, and I'm going to run. Yeah, let's see, remove this one. Okay, great. So now we have the outputs here. So what does this mean? It simply looks like scores to us as well. Is there a way to sort it from high to low? Well, that I leave to you to do. This is a Python. This is not a Python class. This is a data science class. So I'm not going to be talking about this sorting here. But you can actually see that for each of the features, there's been an importance assigned to these features. Okay. For instance, I hope it's numbers in decreasing order. I think so. Maybe so. 0.09. It is more or less 0.03, 0.03. Okay, I think that is maybe, I don't know. But the one with the best feature is proline. Remember, before now we also came out with proline to have the highest score. Like if I go up here, you can see proline, not here. If we go here, you can see proline at the end here has the highest score here. You can see here. Proline at the end here, and here it also gives us proline as the best here. Okay, so this is about feature importance. I think it makes sense to you. So what have we covered? We've covered feature selection, and we said feature selection is necessary for you to be able to visualize or understand your data. You need to reduce it from large number of features of very high dimension to a lower dimension or a lower set of features or attributes. We've covered a number of them. We've covered the last one we did just now is feature importances. We talked about dimensionality reduction, where I told you about PCA. We are going to be doing that immediately after now. And we also talked about recursive feature elimination, RFE. We talked about univariate feature selection. Yeah, so basically we've covered feature selection now. So I'm going to thank you for viewing. Please remember to subscribe to my channel by hitting on the subscribe button below. If you have any challenges whatsoever following, please leave me a comment. So let's now complete this class by doing a principal component analysis in the next class. So let's see.